Good morning, my dear student. Myself Puspita Baske, lecturer in Mechanical Engineering Department. So now I am going to teach you Bell-Coleman refrigerator. Okay. So first of all of you see this one. This is the heading of Bell-Coleman air refrigerator. Okay. So here Bell-Coleman air refrigerator, also known as the reversed Brayton cycle, or that is the Joule cycle. Okay. Actually this reversed Brayton cycle is the modification of reverse Brayton cycle is the modification of reversed Carnot cycle. So before going to that, just I will give you some knowledge about that. Actually this Bell-Coleman cycle is used for frozen meat in sea. Means frozen meat in sea. Okay, that's why this Bell-Coleman refrigerator is developed. Okay. Okay. Now all of you see this one. This is the reversed Carnot cycle. Okay. In this reversed Carnot cycle, P means pressure, V means the volume. This is the PV diagram or PV coordinate. In this PV coordinate or PV diagram, I am showing you the reversed Carnot cycle. Okay. There are 4 type of process. Process 1 to 2, 2 to 3, 3 to 4, 4 to 1. So all of you focused here. Reverse Carnot cycle. Actually this reverse Carnot cycle is modified. Okay. After that we are getting the Bell-Coleman air refrigerator or reversed Brayton cycle. In this case, reverse Carnot cycle, there are 4 processes, means 2 number of isentropic process, okay, and 2 number of isothermal process. Okay, 2 number of isentropic process and 2 number of isothermal process. After modification, okay, after modification, this isentropic process is remaining same, okay, but modified part is this one, isothermal process, means this one. This is the isothermal process that is 2 to 3 process. So here isothermal process is replaced by, this one is replaced by isobaric process. Okay, so isobaric process means here pressure is constant. Okay, in the reverse Carnot cycle there is the isothermal process, means here temperature is constant. Okay, then after modification, that isothermal process is modified into isobaric process. This isobaric process means pressure is constant. Okay, after that we are getting the reverse Brayton cycle. Means reverse Brayton cycle, in that case the 2 number of isentropic process are there and 2 number of isobaric process are there. All of you getting? Okay, then these are the 4 process. These are the 4 process which are showing in your reverse Brayton cycle. Actually that is that one I have explained later. Okay, these are the processes. Number 1 is the isentropic compression process. Then number 2 is the constant pressure cooling process. Then number 3 is the isentropic expansion process. Then number 4 is the constant pressure expansion process. Okay, so here in these four processes, the second one means process 2 to 3. This process is the constant pressure cooling process. Means this isothermal process is replaced to constant pressure process. Okay, so that's why this process is called the constant pressure cooling process. Okay, then next another thing is the isothermal expansion process. In reverse Carnot cycle, there is an isothermal expansion process. This isothermal expansion process is replaced by the constant pressure expansion process. Okay, means here at expansion process the pressure is constant. So these 4 number of processes are included in your reversed Prater cycle, or that is the Bell-Coleman air refrigerator. Okay, so next page I have shown you the schematic diagram of Bell-Coleman refrigerator. Okay, and according to that schematic diagram we have drawn the PV and TS diagram of the Prater cycle or Bell-Coleman refrigerator. Okay, so my dear student, see this one. This is the schematic diagram. Okay, this one is the schematic diagram of the Bell-Coleman refrigerator. Okay, this is the schematic diagram. Schematic diagram of the Bell-Coleman cycle or line diagram of the Bell-Coleman cycle. In this diagram there are 4 components are attached together. 4 components are connected in the circuit system. Okay, they are, first one is the compressor, then second one is the cooler, that is also called as the heat exchanger. Okay, then third one is the expander, then fourth one is the refrigerator. Okay, so see, all of you see this is the compression process. Compression process means this is the process 1 to 2 process. Okay, this is the process 1 and this one is the this is the state 1 and this one is the state. In between the state 1 to 2 there is a compressor process. Okay, so here actually the working medium is the air. Air is the working medium. Okay, air is the working medium. Okay, means this air is circulated throughout the cycle. Okay, so when the air is entered into the compressor, okay, when air is entered into the compressor, in that place the air is compressed by the compressor. Okay, after compressor the pressure and temperature both are increases, and that thing is shown you in your PV and TS diagram. This one is the PV diagram. Okay, this one is the TS diagram. Okay, when the amount of air is compressed by the compressor, means that is the process 1 to 2. This one is the process 1 to 2 in PV diagram. When air is compressed by the compressor, then pressure and temperature. Suppose P1 is the initial pressure and T1 is the initial temperature. Okay, so after compression this pressure is increases and temperature also increases. Means this pressure P1 is increases to pressure T2. Okay, then temperature T1 is increased to temperature. Okay, so here in this PP diagram I have shown you the pressure. The pressure which is increased in the cycle or in the compressor. That is this one is the state 1. Okay, this is the state 2. So in this process 1 to 2, the pressure increases. Means this is the corresponding point state of 1 is the pressure 1. Okay, this is the pressure P1, and the corresponding point or coordinate of this state 2 is the P2. Okay, so when when the air is compressed by the compressor, then pressure increases from P1 to P2. This is the process 1 to 2, means here pressure increases from P1 to P2. Okay, then temperature shown in the TS diagram. Here this is the state 1, means this one is the temperature T1. T1 is the temperature T. Okay, so in this TS diagram I have shown you the temperature T1 increases from T1 to T. Okay, then after that compressed air, actually this air is compressed isentropically. Okay, this air is isentropically compressed. Okay, that's why this graph is like that. Okay, then that compressed air is come to the cooler or enter into the cooler, or that is called the heat exchanger. So in this heat exchanger, the cooling water is circulated throughout the system. Okay, or throughout the cooler. When cooling water is circulated in this cooler, then the amount of heat is absorbed by the cooling water, or amount of heat is rejected from the system. Means the pressure means the temperature in this cooler or heat exchanger, the temperature is decreases. Temperature decreases from T2 to T3 at constant pressure. Here pressure is constant. Okay, means this one, this 2 to 3 process. This 2 to 3 process, here the pressure is constant. That's why this is called the constant pressure. Constant pressure cooling process. Okay, so process 2 to 3 is called the constant pressure cooling process. That means in the cooler, the at constant pressure, the temperature of air is decreases from T2 to T3. It's this one. Okay, that means the amount of heat is rejected from the air. Okay, the amount of heat is rejected. Then next process is this one is the isentropic compression process. Isentropic expansion process. Next one is the isentropic expansion process. Isentropic expansion process means that is the process 3 to 4 process. Means this one. Okay, this one is the expander. Okay, the cooling air is enter into the expander where that is expanded by the expander. Okay. At the time of expanding, the pressure is decreases. Okay, the pressure is decreases from P3 to P. Okay, at pressure is decreases from P3 to P4. Okay, and the temperature also decreases. That is the T3 to T. Okay. Then this air is then again this air is enter into the refrigerator. Okay. In this refrigerator, the air is absorb the amount of heat. Amount of heat is absorbed by the air from the desired space. Okay. From the desired space, the air is the heat is absorbed by the air. Okay. At the time, the temperature increases. Temperature increases from T4 to T1. Okay. At constant pressure. Okay. At constant pressure, the temperature is increased. Okay. So this in this refrigerator, see all of you, this is the brine solution in and this one is the brine solution out. Means in this refrigerator, the brine solution is circulated. Okay. Brine solution pipes is there and that pipe, the brine solution is flowing. Okay. That brine solution absorb the amount of heat. Okay. After that, the desired space is cool or cooling effect is produces. Okay. So in this PV diagram, this 4 to 1 is 4 to 1 is the state 1 or point 4 and this one is the point 1. This process 4 to 1. This process 4 to 1 is called as the constant pressure expansion process. This one is the constant pressure expansion. Okay. Then again, that cooling one air is again come to the where? Again come to the compressor. Then same process is repeated from the compressor. Okay. So this one is the total Bell-Coleman cycle. Okay. Cycle of the PV and TS diagram. Okay. By using this PV and TS diagram, we find out the COP of the Bell-Coleman refrigerator or derive the Bell-Coleman cycle, derive the COP of the Bell-Coleman cycle or Bell-Coleman refrigerator. Okay. So my dear student, all of you understood? Okay. All of you understood or not? Okay. So in this class, this much only. Okay. So next class we have next class or next video we have discussing the derivation of COP of the Bell-Coleman refrigerator. Okay. Thank you.